Assalamu alaikum dear students. How are you? I hope you will be fine. Today is your lecture number 2 of subject design of hydraulic structure, which is for BTech Civil, and the credit hour of this course is 3, and I am your lecturer Engineer Mir Masood Shah, Department of Technology, Saraj University of Science and Information Technology, Peshawar, and this is your lecture number 2. In lecture number 2, we will study about weirs. So, what is weir? If the major part or the entire ponding of water is achieved by race crust and a smaller part of it is achieved by the shutters, then this barrier is known as weirs. Clear? When the storage is done by constructing a barrier and the water is stored through this barrier, so these type of structures are known as weirs. Normally the structure is constructed as shown in figure, in which there is a floor. At the start there are, on the upstream side, there are stones laid or the stones are packed, and this is called falling apron. In the next level there is a concrete bed. Also there are cut-off piles with sheet piles. The first one is called the sheet pile line number 1, or on the upstream sheet upstream sheet pile line. The second one is the intermediate sheet pile line, and at the end it is called downstream sheet pile line. A slope is provided to the barrier or weir according to the design or requirements. In this case it is provided 1 in 4. On the upstream side also crust shutters are installed for extra ponding of water, and this is the modern level, means up to this height the water is stored. On the downstream side a slope is provided of 1 in 5. It also depends on your design and requirements. This whole construction is done of strong material. In this case it is done of concrete. At the downstream side there is a concrete block protection. Also there is a downstream falling apron, which is constructed of packed stones, and the silted water, when moved through this portion, a silt stuck here and the clear water moves on the downstream side. It is also called inverted filter, and this whole area is called downstream protection area. Here are some types of weirs. Number 1 is gravity weirs. Gravity weirs are those weirs which balances the uplift pressure caused by the head of water seeping below the weir. Gravity weirs are those structures which balance the uplift pressure which is caused by the seeping water below the weir, and these type of structures are called gravity weirs. So the main thing in gravity weirs is the weight of the weir through which they balance the uplift pressure caused by seeping water. The next type is non-gravity weirs. On the other hand, if the weir floor is designed continuous with divide piers as a reinforced structure such that the weight of concrete slab together with the weight of divide piers keep the structure safe against the uplift, then the structure may be called as a non-gravity weir. In case of non-gravity weir, the structure is properly designed, and the design structures are properly constructed reinforced concrete structure balance the uplift pressure of seeping water. So the structure which balance the uplift pressure by their RCC or properly designed structures are known as non-gravity weirs. In the case of non-gravity weirs, RCC is to be used in place of brick piers because they have to be properly designed. Where in case of gravity weirs, they are not properly designed and made of stones or bricks or only PCC concrete. Considerable savings may be obtained as the weight of the floor can be much less than what is required in gravity weirs. In case of non-gravity weirs, as the structure is properly designed, so considerable saving may be obtained because the floor thickness is much less than the gravity weirs. Some other types of weirs are masonry weirs with vertical drop, rockfill weirs with sloping aprons, and concrete weirs with sloping glacis. Masonry weirs with vertical drops. Masonry weirs wall is constructed over the impervious floor. Cut-off walls are provided at both ends of the floor. Sheet piles are provided below the cut-off walls. Masonry wall is constructed on the impervious floor. An impervious floor is constructed and the masonry wall is constructed above it. Also, cut-off walls are provided on both the ends. Also, sheet piles are provided below the cut-off walls. Here, cut-off walls, sheet piles are also provided. In this case, not shown, but here with these cut-off walls, sheet piles are also provided. The crush shutters are provided to raise the water level if required. Means for extra storage of water, crush shutters are also installed if extra ponding is required. The shutters are dropped down during the floods. During the floods, the shutters are removed so that the flood water easily pass over the barrier or weir. The masonry weir wall may be vertical on both the faces or sloping on both the faces, or vertical on downstream side face and sloping on the upstream side. The weir wall as shown in this case may be vertical on both sides or sloping on both sides, or sloping on one side means sloping on the upstream side and vertical on the downstream side. So these are the different configuration so that a vertical masonry wall may be constructed, and the rest of the structure is the same. That on the upstream side there is a structure which is constructed of stones or puddles, so that silt is stuck in these puddles and clear water enters in our canals. Also on the downstream side there is a structure constructed of rubble, also known as rubble apron, constructed of rubbles, so that on the downstream side the silted water, the silt from the silted water stuck in this portion. Next type is rockfill weir with sloping aprons. Rockfill weirs with sloping apron, it consists of masonry breast wall which is provided with adjustable crush shutters. Here is the figure. Here is the masonry breast wall which is constructed of masonry, and at the top also a crush shutter is provided for extra ponding. The upstream rockfill portion is constructed with boulders forming a slope of 1:4. On the upstream side, this construction is done with boulders or rockfill material, and the slope is provided 1:4. The boulders are grouted with cement mortar. These boulders are grouted with cement mortar, so they pack each other. So they should pack with each other. And this 1:4 slope means that 1 vertical and 4 horizontal. The downstream sloping apron consists of core wall. On the downstream side, they provide with the core walls as shown. The intermediate space between the core walls are filled up with boulders maintaining a slope of 1 in 20. The intermediate portion, or between these two portions, the rocks or boulders are provided in this portion, and a slope of 1 in 20 is provided, means 1 vertical and 20 horizontal. The boulders are grouted properly with cement mortar. Also, these boulders are grouted with cement mortar. Next is concrete weir. Nowadays, the weir is constructed with reinforced cement concrete. In these days, normally the structures are constructed reinforced cement concrete. The impervious floor and the weir are made monolithic, means the floor and the weir are constructed at the same time. The cut-off walls are provided at the upstream and downstream ends of the floor and at the toe of the weir. Also, cut-off walls on the upstream side and downstream side are provided. Sheet piles are provided below the cut-off walls. Also, the sheet piles as shown are provided below the cut-off walls. The crushed shutters are also provided, which have dropped during the flood. Also, at the top of the weir, the crushed shutters is provided, which is dropped during high floods, so that the flood water easily pass over the weir. And this is the general structure of the concrete weir. The water move from this side, this is the upstream side, and move through this side, this is the downstream side. Here the water stores and the extra water move over these shutters, or when the shutters are removed, move over this weir on the downstream side, and this storage water is used for our required purposes. Next is barrage. If most of the ponding is done by gates and a smaller part of it is done by the raised crust, then the barrier is known as barrage or a river regulator. When a structure is constructed and the ponding is done by gates, or a small partially raised crust with gates, these type of structures are known as barrages. As you can see the diagram of a barrage, they consist of gates and proper structures. A proper structure is constructed and gates are installed, and through these gates water is stored. When we need water, we close these gates and water stores, and when we do not need water, we open these gates and the water move on the downstream side. On the upstream side, the aprons is constructed of loose talus material. Also, a packed stones portion is constructed, and this portion is known as protection area. Also, the upstream sheet pile line is constructed. On the downstream side, there is a CC block with inverted filters and also aprons constructed of boulders, and this side or this portion is known as downstream side protection area. Also, on the downstream side, a sheet pile is provided. The floor is constructed of concrete, and the structure is erected on this concrete floors, and the gates are installed on this floor. The next topic is efflux. What is efflux? The rise in the highest flood level upstream of the weir due to construction of the weir across the river is called efflux. So the highest flood level on the upstream side of the weir due to the construction of weir is known as efflux. In case of weir, the efflux caused during high floods is quite high, but in case of barrage, the gates can be opened during high floods and the efflux will be nil or minimum. In case of weirs, the efflux is high because in weirs there is very less control over the river water, so when flood come in the river, the water level rises to the highest level and efflux is maximum. Whereas in case of barrages, when a flood came in the river, the gates are open and the flood waters is allowed to move on the downstream side, so the efflux is minimum at the in the barrages, as the highest flood level is on the lowest level. If you have a choice between a weir and a barrage, so here is the two choices or 2 points. The choice between a weir and a barrage is largely governed by cost and convenience in working. A shuttered weir will be relatively cheaper but will lack the effective control possible in case of a barrage. So the construction of a barrage or weir is largely governed by cost and convenience in working. Also, a shuttered weir will be cheaper from barrage, but it will lack the effective control which we have in barrage. A barrage type construction can be easily supplemented with a roadway across the river at a small additional cost, as the structure is already built, so at small additional cost the barrage may be supplemented by a roadway, whereas in case of weirs it cannot be possible. Barrages are almost invariably constructed nowadays on all important rivers. And this is the end of our lecture number 2.